Okay, we continue for the part two, application for modular arithmetic. We have first we have a hashing function, and then we have a pseudo random number generation, and then the last one we have cryptography. This one is applied for modular arithmetic. Okay, for the hash function. Okay, basically we want to determine if two objects are equal. Possibly with a fixed average number of mistakes. This one is for the hash function. Then the other is the pseudo pseudo random number generation. Okay, pseudo number generation is also known as deterministic random bit generator. Is an algorithm for generating a sequence of number who those have the properties approximate the property of sequence of random numbers lah. Okay. Sometimes we call it as PRNG, pseudo random number generation, or sometimes we call it as deterministic random bit generator lah. Okay, and then we have prime here. Yes, saya. Ha. Sekejap lagi saya upload. Yang chapter berapa? Section berapa? Section berapa? Yang ada sampai section berapa? Yelah, tu yang section berapa? 3 point? 2.4. Nanti saya ni lah. Saya upload. Okay, yang ni nanti saya upload Okay, and then we go for the prime and grade common divisor. Okay, for example, we have prime numbers. What is prime numbers? Prime number is positive integers, p, greater than 1 is called prime. If the only positive factors p are p and 1. Positive integer that is greater than 1 is not a prime, is called a composite. It can be divided for itself. For example, 2 multiplied by 2 is 4. Okay, 2 multiplied by 3, 2 multiplied by 4, and so on. Okay. Fundamental theorem of arithmetic: every positive integers can be written uniquely as a product of primes. Okay. Okay. Or sometimes we call it as a natural number. Greater than one is not a product of two smaller natural numbers. Okay. Okay. For example, we have 15. We have prime factor 3 multiplied by 5 is a prime factor. Okay, and then we have 48. Okay, we multiply 6 by 8, and then we also can have 2 multiplied by 3 times 2 power of 3, and then 2 power of 4 multiplied by 3 is prime factorization. This one is prime. Okay, for example, you have 13. 13 you have only 1 and 13 lah. Okay, it's a prime number, but 4 is not a prime number because we have a lot. Okay, 1, 2, and 4 lah. It can be multiplied by itself, 1 and 2. So it is not a prime number lah. You have 2 times by 2, 4 multiplied by 1, 1 multiplied by 4 lah. Okay. Okay, if n is composite integer, then n has a prime divisor less than or equal to power of n lah. It is easy to see if n is composite integer. It must have two divisor p1 and p2 such that p1 multiplied by p2 equal to n lah. If p1 is greater than 2 and p2 is greater or equal to 2 lah. P1 and P2 cannot both be greater than power of n. Okay, because P1 multiplied by P2 would be greater than n lah. If the smaller number of P1 and P2 is not a prime itself, then it can broken up into prime factors that are smaller than itself but uh, greater or equal to 2 lah. Okay, and then we have GCD, greatest common divisor. Let A and B be the integers and not both zero. It is very common if you have A and B, both are not equal to zero. The largest integer D, such as D, divide by A, and D divided by B is called the greatest common divisor of A and B. The greatest common divisor of A and B is denoted by GCD. A comma B notation GCD A comma B is equal to D. For example, what is a GCD of 48 and 72? Okay, we have GCD 2 can be divided by 48. 4 also can be divided by 48. And then 2 also can be divided by 72. And 4 also can be divided by 72 lah. And then the positive common divisor of 48 and 72 are 1, 2, 3, 4, 6, 8, 12, 16, and 24. So GCD of 48 and 72 are 24 lah. Okay, then we have what is GCD 19 and 72. What is a GCD of 45 and 60? Okay, we have another example here. Okay, the greater common divisor of set whole number is the largest integer which divide them all. Okay, for example, okay, for example, we have the GCD of 12 and 15. We have 12 and 15. Okay, 12 and 15. First, let's find all the divisors of 12, then we'll find out divisors of 15. We find one by one. Then we find the largest one. So let's first find the divisor of 12. Divisor of 12 is equal to, okay, we find divisor of 12. Okay, okay, we have 1 and then evenly by 1 and every integer of 2. Okay, we have 1, we have 2. And then evenly 3 divided by 12. Okay, we also have 3. And then times 4 is 12, and 4 times 12 is evenly 5. Okay, we have 4. Okay, 4 times 3 is 12. Okay, and then 5 is not equal divided by 12 evenly. You get remainder of 6 divided by 12. Okay, and then you have 6, 5. Tak boleh, it cannot be 5 because we have a reminder. You have 6. Okay, uh, divide by 2 remainder, and then 7 cannot evenly, 8 or 9 also, or 11, but 12 itself does divide evenly every number. Okay, 12 can be divided. Okay, 7 cannot, 8 cannot, 9 cannot, 10 cannot, 11 cannot, and also 12. Okay, is it clear? Jadi boleh faham ke? Mama Rita okey ke? Ain? Boleh Ain? Okay. Ya, ya. Dia tak ada reminder. Kalau 5 kalau kita bagikan dengan 12 tu dia akan ada reminder 2 Okay, then we find the divisor of 15. Okay, now let's look at a divisor of 15. Once again, 1 divided by every integer, 2 is not divided by 15 evenly. Lah. Okay, and then we have 1, 3, we have 1, we have 3. So 3 is a divisor by 4, give you a reminder of 3. It's not a divisor. 4 is not the divisor because if you have 4, you got reminder of 3. Lah. And then you got 5, 1, 3, 5. Okay, and then 50, 5 divide 15 evenly. And then we continue, which divide evenly is 15. So now we have 1, 3, 5, and 15. Lah. Now let's see which divisor they have in common. Lah. Okay, common divisor, we have 1, divide both of them. And then next one we see 3 divide. Okay, we have common. Common. Okay, common here we have 1. And then we have 3. Okay, divide by both 12 and 15, but other than 1 and 3 does not other divisor in common. So the greatest common divisor is the largest common divisor, which is 3 lah. Okay, common divisor, common, we can divide both number here. So the greatest common divisor is the greatest lah. We pick 3 lah. Is it okay? Ketika boleh ke? Nurin boleh? Nurin? We list first and then we pick the greatest, the largest number. Okay, to find GCD and list common divisor for a pair A B, we have three main terminology here. We have division operation, we have prime factorization, and then we have Euclidean algorithm. Okay, for the division operation, GCD 4872. Okay, we have here 2, 4872. Okay, we have 2, 3, and 4. Okay, and then we multiply all the this one, multiply by 3, multiply by 4, and then we got 24. And then for the least common okay, greatest common and least common, we have 2 multiplied by 3, multiplied by 4, and then we also multiply by 2, and then multiply by 3, and then we got 144. Okay, this one mean, this one is max. Okay, we have 2 multiplied by power of 4, 3 multiplied by 2 lah. We got 144. Okay, this one 2 power of 3 multiplied by 3, power of 1, we got 24. Okay, this one least common multiplies. Okay, another example I give to you. Okay, they have various method to calculate or to determine the GCD. The first way that I show to you is we list out. We list out uh, the GCD, the common factor first, and then we pick the greatest common divisor. Okay, we are going to discuss example. First, we start by factoring each one of the numbers. Okay, for example, we have 168 and 100 and okay GCD. Okay, and then we put the table like this. Under 80, 2 divided by 2, 20. Okay, we have one. Okay, by doing factor, we shall arrive at the conclusion that 2 multiplied by 2 multiplied by 2 multiplied by 3 multiplied by 7 and that 180 is equal to 2 multiplied by 3 multiplied by 3 multiplied by 5 is equal to 180 and 168. Okay, in the next step, we shall determine the product common factor with smaller exponent number. Okay, 2 multiplied by 2 multiplied by 3 is a common smaller exponential number for the minimum. Okay, minimum for this one, we have 2. Okay, 2 multiplied by 2 divided by 3. Okay, it's the common. So we got the GCD is 12. Okay, this one we go by the prime factorization. This one is more. This one is by the division operation. And then we have a prime factorization. We have a second and third. If we have a bigger numbers, we go by List-Dian algorithm, exclusion algorithm. Okay, the first one we go by the division operation. Okay, this one is for the GCD and list. Okay, GCD least common multiple. We go by the LCM. Okay, we have D 48 and 72. Okay, and then we have 48, also 72 for the multiplication. Okay, and then we have a prime factorization. Okay, and the other one we list like this. Okay, okay, this one greatest common divisor using prime factorization. Okay, we can compute it using prime factorization of A and B. Lah. Okay, we have GCD 60 and 54. We list out the factorization like this one. Lah. Okay, okay. Then for 60, we have 2 power of 2, 3 power of 1, and 5 power of 1. Lah. And then for B54, we have 2 power of 1, 3 power of 3, multiplied by 5 power of 0, and the GCD is 6. Okay, GCD is 6. Okay, and then GCD or AB is 2 power of 1, 3 power of 1, 5 power of 0 is equal to 6. Okay, this one is for prime, for the minimum. 6, 60, 6, 54. Okay, and then for the least common multiples, LCM, we have 3 42 divided by 42 and 7 divided by 42. This one is least common multiple. Okay, for example, we have denotes the least common multiple A and B by LCM AB notation is LCM AB is equal to M. Okay, the LCM is 3 and 27. Okay, 3, 7 is 21, and 21 minus 21 is 0. Okay, and then the LCM least common multiple, smallest number is 21, and then same goes to LCM for 6. For 6, for 6 is 24. Okay, okay, and then we have LCM 5, 10, 5. Okay, 50 lah. Okay, okay, can I give you more example of this one, I think it's not very clear for division operation, prime factorization, and Euclidean algorithm lah. Okay, which one is not clear? Boleh ke? Yang mana yang tak berapa nak clear? Division ke, prime ke? Benson, are you okay? Okay, please ask which one is not clear. Okay, for division operation, GCD, we have written the greatest common divisor, which is the largest integer that evenly divide all the values. And then LCM is written least common multiple, which is a smaller positive integers that is multiple of all values. And then we have also seen the mode xy that return the remainder of dividing x by y lah, x modulus by y lah. Okay, for example, we have a division operation. Okay, 48. Okay, okay, 2, you have 2 here, GCD, 48 and 72. We list out for division operation. 2 multiplied by is a common factor, 2. Then we have 3 divide by 2. Then divide by 3 is a common. And then divide by 4 lah. Okay, for the greatest, okay, we multiply 2 multiplied by 3 multiplied by 4 lah. We got 24. And then for the least common, okay, 48 and 72. Okay, we multiply all the uh, 2 multiplied by 3 multiplied by 4 multiplied by 2 multiplied by 3, and then we got 144 lah. Okay, this one, if you want to calculate the prime factorization for 24 and 144, we list out the power of, okay, we factorize. Okay, like this, 48, we have 48, then 6 times 8. Okay, and then this one is 2 times 3, this one 2 power of 3 lah. Okay, and then we have uh, 2 power of 4. Okay, times 3, okay, equal to 48. Okay, same goes to 72 lah. 8 multiplied by 9, 2 power of 3 times 3 power of 2 lah. Okay, for the minimum, 2 power of 4 multiplied by 2 power of 3 lah. Then the minimum is 2 power of 3 multiplied by 3 power of 1. This one 3 power of 1 is equal to 24. Okay, same goes to prime factorization for 48 and 72. We list out the prime. Okay, same goes like this one. Okay, boleh ke?